So just a few technical notes to go over first. First is to type in the chat window when you have something to say. Um, remember to mute your speaker. You should have a speaker at the very top. Check the volume levels in case you have any issues there. And if you have any problems at all, please send a message to climatecampaign@globe.gov. So if you will hold on to your seat, I'm going to adjust the screen a little bit. There we go. That wasn't too bad. So welcome to the Globe Student Climate Research Campaign's August webinar. My name is Gary Randolph, and I'll be leading this webinar for the Globe Science and Education team. My colleagues Travis Anderson and Sarah Tessendorf will be monitoring the chat window and answering questions, etc. So if you have any questions, please just type it in. Thank you for whoever got the recording going. Okay, so we'd also like you to type in the chat window. Obviously, your name is there, but if you could type in your role within the Globe program as either a teacher, trainer, country coordinator, etc., and country where you reside. And if you are not affiliated with Globe, please let us know that also. And so, as I mentioned, this webinar is, as the title says, using Globe protocols and data to study local climate. Before diving into how to study local climate, I'd like to go over kind of the program, the agenda that we will be following this evening or this morning, depending on where you are. So what I'll be doing is talking about using Globe protocols and data, including long-term data, making connections to the world around you, and then publishing student research on globe.gov, on the Globe website. As I mentioned, before I dive in to the deep end of studying climate, I'd like to begin by offering some options for introducing climate in the classroom. And let's see, can you I assume that you can see the Globe website. Oops, what happened? I lost the Globe website myself. There we go. Well, now you've lost it. Okay, so let me, good. So first I'd like to show you where some very good activities are for introducing climate into the classroom. And Jessica McCarrow had introduced Exploring the Globe website last month. And I just want to remind you of where some of those activities are. Under field campaigns from Explore Science, the first one is the Student Climate Research Campaign. The first link on the navigation is Climate Foundations. And then here we will find two of our climate foundations, from weather to climate, looking at air temperature data, and then what is your climate classification. We're also working to broaden our knowledge of who has participated in the Student Climate Research Campaign by collecting some user data. So at the bottom of this page is a brief survey on participation metrics besides data entry. So please feel free at your convenience to complete this, and please send it to your colleagues and your teachers so that they can also complete this form and send it back to us so that we have a better idea of how you and your teachers are participating in the Student Climate Research Campaign. So we really look forward to receiving your information. So now onto the topic at hand, using GLOBE protocols and data to study local climate. Climate encompasses data from many of the atmosphere protocols, and we can find the investigations under Explore Science and Investigations. So we can look for temperature, precipitation, humidity, and barometric pressure within these protocols, and those could be interesting things for the students to begin studying. Other things that affect climate are elevation, terrain, and latitude. Now, climate is often thought of as weather conditions that occur in an area over a long period of time, often 30 years or more. If your school has already been collecting data, then continuing this data legacy is quite important. If not, there's no better time to start than today or tomorrow. However, out of the approximately 56 protocols that GLOBE has available, the question is, which should your students focus on? Well, that's a really good question. And the best selection of protocols actually should be developed by teachers and their students based on the local environment. For instance, if they don't have a body of water near their school, they probably shouldn't begin looking at the hydrology protocols, although they should include the hydrologic cycle or the water cycle into their research. And those components of the water cycle could be things such as clouds, humidity, and precipitation. So your students might want to investigate the effects of changing amounts of precipitation on local vegetation, and collecting data on daily precipitation and soil moisture, as well as land cover observations, would provide an interesting set of data over time. Perhaps students are interested in examining snowpack amounts, the total snow accumulation on the ground, on different land cover types, and how it might affect soil, surface, and air temperature. They could collect these data daily as well. How does changing snowpack affect plant phenology? And how does land use change affect relative humidity? So these are just a few examples of questions that students could ask. So GLOBE data only reaches back, in the best of circumstances, just over 17 years. And 17 years of data provides some very nice data sets. So one of the things that we can do is begin looking at some of the data on the new visualization tool. And so once we're in here, we can click on Add Data Layers, and we have several different data sets available to us. But let's choose air temperature. And we have three possibilities for air temperature: solar noon temperature, which is current temperature, maximum daily temperature, and minimum daily temperature. So let's look at maximum temperature, and let's add the layer. Now this will show schools that have entered data on, if we look over here, on 8/20/2012, which is yesterday. However, we can actually manipulate these dates. And if we go 10 years back from today, we actually have a really nice data set. So we can actually begin looking at data from this point on. So we can zoom in. Click on a school, and this, oh, there we go. And this pop-up bubble, which will actually tell us some information. For instance, the name of the school, the measurement information, and also how many data they collected. It also provides us the opportunity to look at a table of data or a time series plot. So first, let's take a look at the table of data. And well, if I can stretch this out, there we go. And so, as expected, it's a table of data with measurement dates, current temperature max, and minimum temperature. And so you could pull this into any spreadsheet program and manipulate those data. And as I mentioned, there's also a time series plot. So we can click on that, select what we want to look at of these three options, and click on that icon. Now we can click on plot, and now it will plot the data for this school. And it looks like they have a gap in their data, which definitely happens in most of the best data sets. We can also begin looking at different data sets and add to this collection. Okay, so here is a school in Thailand. And again, we will look at maximum temperature and plot that. And now you can see that we have both of our schools listed here, and that we also have small X's here that will allow you to remove one of those schools. So now we can plot data as well. And look at the data from this particular school. So we can also begin looking at some of the measurement protocols that we have and the data that we have available on our old site. And so what I would like to do is take you to training at training.globe.gov. And click on the classic website. And wait just a few minutes, and this should look somewhat familiar to some of you. Okay, there we are. And if we select for students, you can actually go to Finding Data and Advanced School Search. And when this comes up, unfortunately our navigation has kind of exploded at the top, but we can go all the way to the bottom where all of the good tools are. And here we can select schools by name or city, by teacher name, as well as by country or by state and province. So let's look at Saudi Arabia, and let's look by those schools in Saudi Arabia who have entered, let's say, over 10,000 data. And that's since the beginning of the program. Even though they didn't begin the program until later, there are some schools that have a tremendous amount of data in Saudi Arabia. And I come down to the bottom, and voila, we have, how many schools do we have? 15 schools that have 10,000 data or more. So let's select the first one here with the most number of data, and let's make a graph of these data. Again, wait in just a moment. And there we are. We have a graph of the data from this school in Saudi Arabia. And then you can begin manipulating data, adding data sets, and exploring connections through this earlier visualization tool. Now, the visualization tool I showed you before, and I'll just click back there right now to remind you, this is still under development. And so while this is being developed, feel free to use this, but also you can use our tools on the training site to also explore from using many more parameters. So as I mentioned, in the best of circumstances, globe data only span 17 years at the most. Excuse me. And if we are to look at longer periods of time, the question is, how could we begin to do that? Well, we actually have a way to look at some longer term data. And so we can go to our Student Climate Research Campaign page under the Climate Foundations, and under From Weather to Climate. And on this page, we actually have access to some data that are downloadable onto Google Earth. And this is called sizzledata.kmz. Sizzle is a group that is managing the Global Historical Climatology Network data set. So we will open this in Google Earth. And I need to, one moment while I stop sharing that and I look for Google Earth. Okay, there we go. So here's Google Earth. And so what we can do, if you look over here on the side, it says Sizzle GHCN version 3. And so we can zoom in by double clicking. We can also use this. And we'll see that there are pin drops of different sizes and colors. Green is temperature and precipitation. Yellow is temperature only. And light blue is precipitation only. The size of the pin drops also tell you something about the data. So those larger pins have data that are within 6 months, and the smaller pin drops are those that do not have data within 6 months. And so let's look at this. This will tell us, so double clicking on one of the one of the pins will tell us the name of the site and latitude, longitude. A little bit of information about the temperature data, the range and the number of complete years, which is 43. Precipitation data and those dates, and then 81 years of data. It also gives us the option to look at the monthly data or the yearly data. So looking at a long-term data set, you may or may not want to look at the monthly data. It could be quite busy with 81 years of data for precipitation, or even 43 for temperature. But let's take a look and see what that looks like. And so if we click here, and I will also need to stop sharing and share my Excel. So one moment. Um, okay, please bear with me. And there's my Microsoft. Okay, so I hope that this is coming. There it is. Okay, so now we can look at our temperature and precipitation data for this location in Benin. We'll see that it begins in 1921, and there are precipitation data, but there are not temperature data. And as we noticed in the pop-up window on Google Earth, it did say that there were 43 years of temperature and 81 years of precipitation. So logically, there would be less months of temperature data, but we can still go through this and look at all of these data that are available. And again, this is monthly data. One of the interesting things is looking at 3 straight months of no precipitation, and then we have another 6 or 8 months of fairly significant precipitation, and then again several months of no precipitation, and then significant precipitation and no precipitation and significant precipitation, and so on. And so that looks like an interesting pattern, and so that could be something that students would be interested in exploring. Perhaps not only this site, but they could also go back to Google Earth and look for nearby sites, either further inland, closer to the ocean, or on the same latitude, and begin exploring to see if they see the same pattern of several months of no precipitation, followed by several months, a good number of months with pretty significant precipitation. And we can also come down here a little ways, I think, and we should be able to find some temperature data. And there we go. So temperature data also is begins in 1965 and goes through, if I recall, it's 2012 or 2011. Yes, so through 2012. So one of the interesting things that you can do. And I won't go through a course in using Excel because that's not why we're here. But what I would like to do is just show you quickly what these data look like when you have all of these data into a time series plot. And so we can begin to see how these data look for monthly data, which is incredibly busy. And we can also look for, where's our temperature data? And so we can also look for our temperature data. And you will see that it does look like it has an interesting seasonal pattern. However, look at the maximum and minimum temperatures that we're looking at. It's mostly between 25 and 30 degrees Celsius. So it's not as in you would imagine from the northern hemisphere, where you see these great seasonal patterns. While it still has that shape, it doesn't have the extent of the temperature range. And this is something also that students can begin exploring, is looking at this pattern and looking for patterns significantly different or significantly the same in different areas of the world. If we had this area in Benin compared with an area in Saudi Arabia or Bahrain, with an area in Alaska or Norway, and getting students to really think about what are those seasonal patterns and how do they fluctuate and how do they change over time. And so some of these data go back past 100 years. And so students can really get a great picture of what has been happening at these locations for many, many decades. So making connections between protocols also will help students begin to see Earth as a system. And so studying land cover or biomes along with air temperature and precipitation will directly connect to the what is your climate classification activity. And so the Köppen-Geiger climate classification system is a great place to begin looking at land cover as defined by climate. Phase 2 of the Student Climate Research Campaign is also including phenology to our collection of intensive observing periods, or IOPs. Phenology is the study of an organism's response to environmental conditions and is an excellent way to study both climate factors, principally air temperature and precipitation, along with some simple soil measurements, soil temperature and moisture, along with the timing of the beginning or the ending of the growing season. And so as the growing season begins, the buds of trees will begin to swell and eventually breaking open to allow the leaves to emerge and grow. The conclusion of the growing season is often marked by leaves changing colors and dropping off. This is much easier to follow in deciduous plants and grasses. Last but very far from least important is student research. So collecting data is fun. It's fun to get outdoors for a while and get out of the classroom and actually collect data. But hopefully, as you've seen here, once you get into looking at data, it can be much more interesting. Many more questions come up, and students can begin not only asking questions but also looking for the answers to those questions. So therefore, it's really important to get your students looking at data, writing up their research for a larger audience. And like I said, this is where the fun really begins as students begin to analyze data and discover answers to their questions, as well as the many answers or the many questions that are still unanswered. So once students have finished their research, they should share it with their peers in their classroom and school, and then finally to the Globe community via the Globe website. And I'm going to stop sharing that for just a moment. And come back here just to refresh your memory on one more thing that Jessica had mentioned, and that is how to share how to have your teachers share their data with the Globe community. So when you come here to your school, and I will just choose India as my country, and I will choose a random school. And on this page, you will see the Tell Us About It box. And if you click that, it will actually provide, nope, you can't see that either. It will actually provide a box that says Tell Us About It with file name. Well, I won't worry about that. File name and more information that you can add about that, that document that you're uploading. So we really encourage you to share that with your teachers and your colleagues because we really want to see what students can do with their data. And so I am going to stop sharing that and come back to our plan. And so we have covered all four of our items, and just one final screen that I'd like to go over some important dates coming up. So this month through July 2013 is the Phenology Climate IOP. So whenever it is appropriate for you to begin looking at your plants and how they are changing due to either senescence or the beginning of the growing season, please do so. So let's see, we just finished, this is the conclusion of this webinar, so that is no longer valid. 30th of September is the completion of the climate campaign calendar competition. And so submissions are due on the 30th of September. So please share that with your teachers, with your colleagues, with your students, so that we can get lots of fantastic art and photography in, so that we can have just a horrible time trying to decide between these amazing pieces of art and how we're going to choose. September 2012 is the Great Global Investigation of Climate IOP. The 11th of September is the next webinar, and that webinar is on scientist skills, how to develop a research question. And please look for the times of these webinars in the Globe News Brief and on the Globe website, the SCRC page. October 2012 is the CLC, the Climate and Land Cover IOP. Looking further ahead, Earth Day 2013, our video competition will be coming to a conclusion. And so we need to have your students, even now, beginning to think about their videos that they want to produce. And finally, May 13th is phase 2 will actually conclude with a virtual student conference. And more information will be forthcoming on that. So we have time for questions, comments. In general, thank you very much for attending. And thank you to my colleagues for monitoring the chat window. And please let us know how we can help you by answering questions now, or if you have questions even after the webinar is over, remember that you can contact us at climatecampaign@globe.gov. So thank you very much for attending. And please feel free to ask us some questions or share your comments. And again, just to remind you, really important to have lots of submissions for the climate calendar competition, and those are due on the 30th of September. Hi, Judy. We look forward to having your students involved as well. Hello, Nora. I was so busy with the webinar I didn't see you had joined us. Hope you're doing well. You're very welcome. And this and other webinars are available to view on our SCRC page. Actually, if you go to the, actually, let me just go there. So if you go to the teaching and learning and professional development, oh, it's not coming yet. There it is. Teaching and learning and professional development resources. And then you will see one of the tabs is webinars. And one of those links is SCRC webinars. And here we have a listing of our webinars that we've had. They are either in Adobe Connect or in YouTube. And so feel free to watch those as many times as you wish. And just to make sure that you are aware of all of these important dates, I'll put it up here again. So, Judy, I read that your school starts in 2 weeks. Wow. I think my son would love to go to your school. He started last week. Third week of June. Now, that would be ouch. Of course, I'm sure he would prefer to have the best of both worlds, as wouldn't we all? Okay, good night, Judy, and thank you for participating. And we look forward to hearing from you again. And so it's just up to Leonard